Questions on the first two? Really, the big difference is that in this one and this one, we're multiplying. This one, we're adding and subtracting. This is called combining like terms. You're adding and subtracting the numbers in the front. The exponent doesn't change at all. These might change the exponents because we're multiplying two things together. If you multiply x squared times x to the third, that becomes x to the fifth. You don't need like terms to multiply. You do need like terms to add. You're not allowed to add those two because they have different exponents. So that is really, that's as simple as that gets. Yep, Jason.
I got negative x, negative 6x plus 12.
So we're multiplying negative 3x times negative 4x. We're multiplying negative 3 times negative 4, that's the positive 12. And we're multiplying x times x. X to the first times x to the first. We're adding the exponents. This doesn't have a new exponent because we didn't have an x on that one. It's just 1 times that. It stays exactly the same. This is an x, that has an x. We add those exponents. That's x squared, x to the first. Still just adding the exponents, that one. Any questions about any of those? Everyone's okay on the difference between combining like terms and laws of exponents? Yes. Alright, so now we're going to be multiplying two polynomials together. A polynomial is basically just something with more than one term. Polynomial. The prefix poly just means many. So it's just saying many terms. That's really all that means, many terms. We could also have, don't write this part down, it's going to take up too much space, but a binomial or a trinomial. That's 2 terms, that's 3 terms. Okay? And what I mean by a term, that's 1 term. Actually, that's still just 1 term. Stuff that's being multiplied doesn't make a new term. When I start using addition or subtraction, those add on extra terms. That's 1 term, that's a 2nd term, that's a 3rd term, that's a trinomial, there's 3 terms. Binomial would be getting rid of this negative 3. That's also a polynomial. Polynomial just means there's more than 1 term. So we're going to learn how to multiply that kind of stuff. Before we really get into that, I just want to talk about it as an area because that's the way I think of this. Really, at least that's the way that makes the most sense to me, why that math works out. We're going to learn how to do it without the area, but I just want to show you with this. Really, it breaks down every part that you're doing. What is the area? Well, eventually we want to figure out the area of the entire thing. What do you mean by x2? So that, yep, that's x squared. Because we're multiplying length times width, x times x, x to the first times x to the first. We add those exponents, that becomes x squared. Okay. What is that block? And now this one, it's also x by x. We're still just multiplying length times width. It's the exact same thing. That's still x squared. That's supposed to be a 2. What about this block? What's the length and width of that, Jason? Just 1x. I'm going to write that as 1x. You don't actually need the 1. I'm going to write the 1 anyway. What about this block? Come on, what's that one? That's also 1x. It's 1 times x. That's 1x. Eric, what's that one?
1x.
That's also 1x. Sebastian, what's that one? Also 1x. What about this one on the bottom? Now that one's also a 1x because this is 1. This is an x. What about these yellow guys at yellow at the bottom? Each one is 1. That's a 1. That's a 1. 1 times 1. That's 1. So the area of that entire thing is just adding all of those together. Okay? Hold on. I have x squared plus another x squared. What does that give me? Not x to the fourth. We're not combining exponents at all. 2x. 2x squared. I have one of those and one more of those. Now I have two of those things. That didn't change. The exponent does not change. Now I have 1x plus another 1x plus another 1x plus another x plus another x. How many x's do I have? 5. I have 5x. Nothing about the exponent changed. I'm just adding those up. Really, I'm just counting. And just plus 2. Yeah, that's 1 plus 1 is 2. The total area is these put together. 2x squared plus 5x plus 2. That's the full area of that big rectangle, the whole rectangle. What's the length of that rectangle? What is, if I'm going to call, it really doesn't matter which one's length and width, but what's the length if I'm calling that the length? What's that? X plus 2. Yeah, it's x plus 1 plus 1, x plus 2. What is the width?
X plus 2x.
2x's plus 1. 2x plus 1. What do you mean? I'm looking at the length and width. That's 1. That's x, so I'm multiplying 1 times x. That gives me 1x. This is the answer to that problem. When we multiply length times width, we get that. This is a long, drawn-out way to do this. It's going to get a little bit shorter in the next one and then much shorter in the final process. I just want to show you why this math really works out. The next one, I'm going to split this up. That came out like that. That says 2x plus 3. I'm going to split this up. I'm splitting it there and there. I'm going to find the area of each of those rectangles and then put it together. What's the area? Let's do the easy one first. What's the area of that rectangle? So I'm splitting it so that this is 4x, this is 8, this is 2x, this is 3. James, what is that? Yep, it's 8 times 3, that's 24. That's just a rectangle, that's 8 times 3. What is the area of this rectangle? 8 times 2x, what is that?
16x.
That's 8, that's 2x, that's 16x altogether. What's the area of that bottom left one? I can get 12x. Yep, 4x times 3, 12x, and the last one, Jason, what was it? What's the exponent of that? If we do 4x times 2x, what's the exponent of that? Yep, 8x squared. So now we have the area of that, and that. Actually, this is the process that we're about to learn. It's called foiling, but it's basically just an acronym to memorize how to do this. Really, that's all we're doing. We're multiplying this times this, and then you multiply that times this, and then we combine like terms. Riley, where are the like terms in there? What's the other like term that we combine with that? Yeah. Those two can combine, that makes 28x. We have 24, that doesn't have an x attached to it, so that can't combine with anything. I'm just going to write that as plus 24. And this 8x squared also doesn't combine with anything. I'm going to write it in front just because that's the biggest exponent. Usually you'll see that decrease in exponent. it doesn't matter which order it is. You could write it like this. Those are the exact same thing. Yeah, Brian. Any questions on this? I multiplied the length times width for this one, 4x times 2x, 8x squared. They each have an exponent of 1. So I'm adding the exponents. Because this one, this 2x has an x, that 8 is not an x. We just multiply the numbers. That is basically the area version of what we're doing right now, which is called foiling. That's just an acronym. It doesn't explain any math. It's just an acronym for how you can do this in the beginning. Honestly, I don't follow foiling every time. There's a specific order to this, and I'm going to teach you that way, just so you can get in the habit of doing that very carefully. But there's going to be times when I'm not going to do it in that right order. It's not like it's incorrect. I'm just not following the exact acronym and steps there, but it doesn't change the answer. The acronym really stands for, it stands for the first, they're going to call this inner and outer. I'm going to call it outside and inside. It's the same thing. So first, outside, inside, and left. And it's really just steps for how you can do this carefully. Again, you don't need to do it like this every time. You'll start to see it quicker than this, where you don't need to do this exactly in that order. When I say the first, so also, this is all multiplying. We're multiplying the first term from the first set of parentheses times the first term in the second set. So I'm just doing 10x times 3x. Yeah, that is 30x squared. I'm now going to multiply the outside terms. And when I say outside, I mean the outside of the problem, like the whole problem, 10x times negative 2. Doesn't change the x at all. I'm just multiplying 10 times negative 2. That's negative 20x. And then I multiply the inside of the problem together. The inside is these two numbers on the inside, or two terms on the inside. That and that. It's negative 5 times 3x. That's negative 15x. Again, the x doesn't actually change. Just multiplying the numbers in the front. Which part's confusing?
Why does 10x times 3x equals 30x?
We have an exponent of 1 on each of those. We multiply the big numbers together and add little numbers together. We multiply the coefficients and we add the exponents. Then we're going to multiply this negative 5. I'm going to explain it in a slightly different way in this one. Negative 5 times negative 2. Those are the last numbers, the last terms from each set of parentheses. I'm multiplying the last one in that one and the last one in that one. Negative 5 times negative 2. That's 10. And then I'm going to combine like terms. Eric, what like terms do I have there?
Negative 20x and negative 15.
Yep, negative 20x, negative 15x. I'm combining those. The 30x squared doesn't change. These combine to make a negative 35. That is a positive 10. I'm going to write that as plus 10. That is your final answer. multiply these two together to get that full expression. And really the way you can think about this when you see that problem is that you're really distributing a choice there. You're taking everything from here and distributing it into everything in the second set. 10x gets distributed into there, and into there, and the negative 5 gets distributed into there, and into there. We have to distribute this entire thing into both of those. Yep, just, yep, negative 5, negative 2. Yep. Okay.
We only spoil if there's 2.
Yep, that's important. Yeah, this only works if there's 2 of these. It doesn't work when we have a third. That's why it's just a way to memorize a specific type of problem. It's not really it's not any sort of math, it's just a way to memorize. Explain it? Okay, so just speak loudly, because actually I'm recording this for everybody who loud as can.
Yeah, I got this.
You want to do it?
Can
Yeah.
I do it even then? Can I do it?
I heard Jaden first. Speak towards the computer or...
So you multiply this and this. So I mean the first terms, and it will be 10x squared.
Show how you got that. Where did the 10x squared come from?
Multiplying.
Yep.
And then and then after that you multiply the outside terms, and that gives you negative 2x. And then you multiply the inside terms, and then you get 15x. And then you multiply the last term. And then it's negative 3. And then you combine like terms, and you combine these, and then it's 13x plus
Any questions about anything that we did? That was perfect. Any questions about anything there? Now, if you didn't follow that, please ask. Well, you wrote it out differently than I did, but it really doesn't matter. As long as you're getting each combination, 2x and 5x, 2x and negative 1, 3 and 5x, and 3 and negative 1, and you combine like terms, that's really all you need to do. Any questions before we go on to the next one? We're going to talk about that one. All right, so again, make sure you get every combination. 3x times 6x, 3x times negative 1, and then negative 4 times 6x and negative 4 times negative 1. Try that on your own. Right now. Any questions on number 2? We're going to talk about at least 3 and 4 together. Questions on 2? Any problems with that?
Yeah.
So here I'm just showing what I multiplied. 3x times 6x. That got me this negative 8, positive 18x squared. You get these two middle ones?
Yes.
And then I combine those to make negative 27.
Yes.
No, because we only multiplied x times just a number. It doesn't change the exponent there. This is an x times an x. That does change the exponent. Now, a number times an x doesn't change the exponent. It just multiplies to make a new number in the front. Negative 4 times 6 doesn't change the x at all. We're just multiplying that number in front to get that new number. Okay? And then this is just two numbers being multiplied. That's just positive 4. It's not that easy to check yourself to make sure that you did that stuff correct, because if you don't remember exponent rules, it's not like you can really check yourself, but you can just plug a number into here. If you want to plug in, I would use 1. You can just plug in, listen, if you want to check yourself, especially on a multiple choice question, you can work backwards from the answers. You can take x, plug it into that answer, and plug it into the original problem, and it should give you the exact same thing. Plug in 1 there, 18 minus 27, that's negative 9, plus 4, that's negative 5. I'm going to plug it in there too. 3 minus 4 is negative 1, times 6 minus 1 is 5. Negative 1 times 5 is also negative 5. So you can plug it into the original thing and the answer that you get, and make sure that you did that correctly. Next one. We have x's and y's. It doesn't change the process at all. We're still just multiplying the first times the first times the second, and then the second guy times the first one in the second thing, and the second one in the second. So we have 2x times 4x, 2x times negative y, and then negative 3 also gets distributed into there. Negative 3y times 4x, and negative 3y times negative y. So it's the same setup right now. All I did was just FOIL. I did the first one times both of those. I didn't do it really in the right order, but I just did every combination. What does this bottom one give us? Negative 3y times negative y. Yep, what's that?
3y squared.
Yep, 3y squared. It's y to the first times y to the first. And it's basically a negative 1 times a negative 3. That's positive. What does the top one give us? 2x times 4x. What's special?
8x squared.
8x squared. What does this second one, this orange one, give us? Yep, negative 2xy. Really, almost changed nothing there. X times a y, it's the same thing there. It's still just x times y. We just dropped that multiplication symbol. This is kind of the same thing. I'm going to change the order of that. It's going to become negative 12, also xy. I'm still just multiplying an x and a y together. Richard, where are the like terms there? What like terms do I have now?
The 2x negative y, the other negative 12.
Yep, the xy's are the same. These have exponents, so we can't combine those. So that is y to the second and no x. It's missing an x, so we can't combine it with those. So we're just going to combine those two middle ones. 8x squared minus, this becomes 14, negative 14 xy, plus this 3y squared. And that is our final answer. There's no like terms in there first. Any questions on that? All right, number 4 is probably not what you're expecting. Everybody's first impression is to just distribute that into there and get 25 x squared and either plus or negative 9. That's not right. That is not what we're supposed to do. No, we're not just squaring both of those inside. We're squaring the entire thing. That whole 5x minus 3 is squared. This entire thing is multiplied by itself 2 times. That whole 5x minus 3, that whole thing is being multiplied by itself. Those are the exact same problem.
So I guess supposed to know when you distribute
This is a really good question. Please listen. It's a really good question, and people who are overly confident are just going to make that same mistake over and over. So we're not distributing the 2. The reason we can't really distribute that 2 into here, that can't happen, is because we have an addition or subtraction sign in there. Really, if that's adding or subtracting, you can't do that. If this was like this, where there's just multiplication in there, or if we even had division in there, we're allowed to distribute into that. We would distribute it into everything in there. Because it's just multiplication and subtraction, or sorry, just multiplication and division. Okay? If it's subtraction or adding, you're not allowed to do that. Okay? So actually, you can finish that one on your own. Finish that one, and the next 2, you're going to do 4, 5, and 6 on your own. Get those checked before you move on. All right, any questions about the 3 at the bottom? The answers are up there. Check those. Any questions on those 3? Even if you think you got this, please listen now. All right, so it doesn't change anything about our steps, but we're still just distributing that front term into both of these. 2x squared times 3x. We multiply the numbers in front, so that gives us 6x, and we're multiplying x squared times x to the first. We add those exponents, that becomes x to the third. You get on that side? And then 2x squared times 4 is 8x squared. We just multiply the numbers in front. Negative x times 3x. That was the most common mistake I saw. You just wrote negative 3x, but we have an x to the first and an x to the first. That becomes x to the second. We're adding those 2 exponents. Okay, so we're multiplying 2 x's together. So that means we have to add those exponents. Okay. And then I'm multiplying these 2, negative x times 4. That's just negative 4x. Then I'm combining these 2 in the middle. 8 minus 3. I don't touch the exponents, it's just expressed with 3. 8 minus 3 is 5x squared. The exponent does not change. And we just tack on that extra negative 4x. Any questions on any of that? We can't use FOIL on the next example. No, you can only use that when there's 2 of them. But it's really not changing anything about what I just showed. The distributing is really what I want you to see. We're distributing everything from the first one to everything from the second parentheses. That's all I'm going to say here, really. I'm just breaking this down into multiple steps. We're multiplying the first term from the first set of parentheses by everything in the second set. I'm just going to show that with arrows here. I'm multiplying that into everything there. And I'm going to repeat that step 1 with the second term. That second term, that negative 1, also gets distributed into everything. And like always, combine like terms. So all I'm going to do, I'm just going to show the answer from that. I'm doing x times x squared. That's x to the third. Then I'm doing x times negative 3x. That's negative 3x squared. And then x times 5. That's 5x. So all I did was really distribute that x into each of those. I'm going to do the same thing with this negative 1. Negative 1 times x squared is negative x squared. Negative 1 times negative 3x is positive 3x. And negative 1 times 5 is negative 5. Just distribute the first one and then distribute the second one. Where are my like terms in there? William, where are my like terms? We got one set of like terms. We got 2 like terms. Yep. 5x and 3x. Jason, what did that give us? That combined to make 8x. What's the other set of like terms in there? Brian, what are the other like terms? In this set of terms that I have, what are the other like terms? Yep, those two can also combine. Let's write these two are combining to make negative 4x squared. There's a positive 8x from those two. I'm going to write a plus sign in front of it. I have a negative 5 from there. I'm going to write that at the end. And this x to the third doesn't combine with anything. I just write that in the front. Usually that's the order that you're going to see it. It doesn't really matter, but usually you'll see it go down from 2, 3, 3 to 1, just in decreasing order. That is your final answer. Finishing this practice is going to be your homework. I'm going to have you start it now. When you do this problem, pick one of these two. If you want to use the area, use that. That's fine. If you want to use foiling, that's okay too. That's good. One. No, you're doing this page, this one. You're doing that page front and back. You have 10 minutes, 8 minutes now.